with a previous year question in both mains and all right. I won't give you the options because right now it's not a stage for options. You should know the concept behind it. Well, x is equal to minus 2 by 3t square plus 16t plus 2. The position of a particle is given by minus 2 by 3t square plus 16t plus 2. What does it mean? At any instant of time, I can find where the particle is. I can find the address of the particle. Okay, given that at any instant of time, I can find the position. All right. Question is, when will when will the body come to rest, or when will the particle come to rest? Okay, come to rest. When means, am I asking the location or time? When do you
Time.
have breakfast?
Time, sir.
When do you sleep? It all deals with time. What will where question, what does this deal with?
Position.
Position or location. But here I'm interested in time. When will, at what time will the body come to rest? Take a minute, recollect all the necessary concepts that you know to do this. This is a mains previous year question, NEET previous year question. Both of them have asked us the same question. So, well, let's try to do this. Position is given by this much. When will the body come to rest? There is an easy way, there is a hard way. You can choose either of them. But you won't know, obviously, you won't know which is the easy way, which is the hard way. That's only after a discussion. Yeah. If a particle comes to rest, which quantity becomes zero there? Does it accelerate? Does its acceleration become zero? Does its velocity become zero? Or does its position become zero? I am at rest. So which quantity is zero for me?
Velocity.
Velocity.
Velocity becomes zero. So what is the question's motive? The question is trying to ask, at what time will velocity become zero? Well, given the relation between x, between the position and time, how will I get to know the relation between velocity and time? Doing what operation will give me the relation between velocity and time, given the relation between position and time? I know position and time. From here, I need to go to velocity and time. What should I do? What harkat, what operation should I do such that from xt I go to vt? What should I do? What operation should I be doing? Recollect all the formula. What is the first formula? V is given as dx by dt. What is a given by? Acceleration given by d v by dt. Then, is there any alternate form of acceleration? Yes, it is also given by v dv by dx. Have I discussed this? I remember twice I have mentioned in the class. V dv by dx. Acceleration can also be expressed as v dv by dx. Anybody remembers?
Yes, sir.
Yes,
Yes. Do
sir.
you know the derivation? How it is v dv by dx?
Yes.
Why? Yeah, Apeksha, can you run me through this one? How to get,
We
yeah,
multiply and divide by d
x.
dx itself,
Correct.
and then we take dv by dt or d.
X by dt as
Yes,
v,
sir.
then we get v dv by dx. Cool. Okay. So, what should I do here? Which formula should I consider? I need a time at which it comes to rest, time at which velocity becomes zero. It is obvious that I need a relation between velocity and time, but I know distance and time. How? How can I relate velocity to distance and time? Equal to dx by dt. So v is equal to d by dt of x. But instead of x, what will I write? Minus 2 by 3t square plus 16t plus 2. Instead of x, I substituted minus 2 by 3t square plus 16t plus 2. Well, how do I calculate the derivative of this? A long expression, a lengthy one. How do I do it?
So we do it for individual.
Individual. What is that principle? Again, I write the principle for your clarity. The derivative of a sum is equal to sum of individual derivatives. So does it make sense? This is a derivative of a sum. So how should I calculate? I should add the derivatives of the individual terms. So what is it? D by dt of minus 2 by 3 t square plus d by dt of 16t plus d by dt of what is left now? 2. Now minus 2 by 3 is a constant, so it comes outside the brackets. So minus 2 by 3 d by dt of what is left inside? T square plus 16 is a constant, it comes outside, so I have 16 times d by dt of t plus d by dt of 2. Can you use a formula which you know how to of finding derivatives to get the expression at this stage? Can you do that? Check yourself. What is that formula which we discussed? Derivative of x power n is
N into x power
n minus 1. Since you are dividing, powers should be reduced. N minus 1. Power you are reducing. Okay. But here instead of x, what do I have? Derivative of t square. First we will take derivative of t square. So in place of x, what will you substitute?
T.
T. In place of n, 2. Do this. Try to do this and tell me the final expression. Take a minute because this hasn't been done before. You will need more of practice to do such the derivatives part. Take it easy, chill, be chill, and then do this. Be calm and do derivatives. This was one of the t-shirt given to me by our seniors in during engineering days. So yeah,
2T.
2t is the answer. Correct. 2t. 2t. Why 2? Because in place of n, what do we put? 2. In place of x, what do we put? T. The answer is 2t. So what will I put here? Minus 2 by 3 into 2t. I got the first term. How will I get the next term? This is the easiest thing you can do. dt cancels with dt and you're left with only
16.
16. The next one is still an easier, it is even more easier job. Derivative of a constant. What is the whole idea behind derivatives? Change in a quantity with respect to change in the another quantity. Is a constant going to change anytime?
No,
No,
sir.
sir.
Even if you grow old 100 years, even if you live long enough, 125 years, this is not going to change. It's going to remain the same. So what is the change in a constant?
Zero.
Change is 0. So what is this answer?
Zero.
Can you now tell the complete expression? It is minus 4 by 3t plus 16. Well, what is this? What are we doing? We are writing, we got velocity as a function of time. But the question is, when will particle come to rest? So we need to find the time at which velocity becomes
Zero.
Zero.
0. Can you do that? Minus 4 by 3t plus 16 should be 0. So 4 by 3t should be equal to 16. 4 cancels with 16 as 4. 3 goes to the other side. What are you left with?
Well,
So at 12 seconds, at that time, you can find the particle at rest. That is the best time to hit anybody because they are at rest. The particle cannot protest. The particle cannot cry because it is at rest. You can do whatever you want with the particle at what time? Time equal to 12 seconds. How did we predict this? We predicted this with the help of V equal to dx by dt relation, and we have this minus 2 by 3 t square plus 16t plus 2. This is kind of a horoscope. At any instant of time, I know where the particle is. From this information, I needed to know at what instant is velocity 0, at what instant the particle comes to, or what instant is the particle at rest. This is the technical way. There is an easier way to go about this. Before I tell you the easier way, Tejas, are all steps digested? Do you have some queries? Something?
No, sir, no queries.
No queries? Wonderful. So let us go to the easier way now. What is the easier way? Whenever I see this x depending on t square and t, immediately it rings bell in my head because I know a similar relation derived already. What is it? X is equal to ut plus half at square. Isn't it?
Yes, sir.
Isn't this and this somewhat similar? Look at this. Minus 2 by 3 t square plus 16t plus 2. What is the only difference? Here, there is no constant term. There we have a constant term. See, minus 2 by 3t square plus 16t plus 2. Can you compare this? Immediately when you try to compare these two, what was the original equation which we had got while derivation? This was not the one. The original equation, if you remember, it had something like this: s minus s naught is equal to ut plus half at square. Remember this, the board derivation?
yes.
Yes,
Yes,
sir.
later we equated S naught to 0. Initial, we told that it began from origin. Need not be. If you take S naught to the other side, what do you get? S is equal to ut plus half at square plus S naught. Now, try to compare this equation with this equation. What all properties you can get from the comparison itself? You can get many properties. First, what is the initial position of the particle? 2 meters from the origin, right or left?
Right. So,
Why right? Because it is
uh,
plus 2. Good. Second, what is the coefficient of t here? 16. What is the
16.
coefficient of t here?
U.
U. So can I tell u is equal to 16 meter per second?
Yes, sir.
So what is the initial velocity of the particle? 16 meter per second. Is it towards right? Is it towards left?
right.
Right.
Why? Positive. Any positive quantity towards right. Now, most important one. What is the coefficient of t square?
half a
Half a. Coefficient of t square here?
minus 2 by 3.
Half a equal to minus 2 by 3. So what is a?
Minus 4 by 3
Units?
meters per second square.
What is the practical implication of this? Well, initially it started to move towards right, but it has applied brakes because acceleration is towards left. You got it? Why acceleration should be towards left? Minus 4 by 3. So this negative sign indicates that acceleration is towards left.
Left.
Okay. Initial velocity towards right. So what might happen?
Body slowing.
The body is
Slowing down.
the body is slowing down. Correct. Body is slowing down. A very good answer. The body is slowing down. Well, after this, what can be done further? Anything further we can do from this? What is the question? At what time will the particle come to rest?
Yes.
So we know V is equal to U plus.
AT.
Correct. What should be V when you are at rest? What will be the velocity?
0.
0.
What is the initial velocity, kids?
16.
What is the acceleration?
Minus 4 by 3.
So at what time will you get can you solve this equation then? T equal to
12 seconds.
12
12
seconds.
seconds.
This is an easier way. Okay, shortcut. But you should, for this shortcut to work, you should look for, whenever you are looking at the relation between x and t, you should always look for t square and t dependence. Whenever x is dependent on square of time and linear in time, time itself, t power 1, then you can definitely compare it with this standard form, get whatever you can information about the particle, easiest way. Otherwise, general way is always there. Calculus to the rescue. You do d by dt, equate it to 0, get the time as well. You can do that also. But this in one shot reveals many things. See, in one shot it revealed the acceleration is constant, initial velocity is this much, in which direction it is moving, in which direction it is accelerating, and what was its initial position. You see, entire the particle's history, the future and the present has been revealed by the comparison. But calculus, we can only predict whatever time instant we are interested in. Here we couldn't predict acceleration is negative, initial position and all. That idea that generally we wouldn't substitute here to get. But here definitely by comparison you can reveal many things at single shot. So this was the first question of the day, a mains question and a neat question. Any doubts you have here, you can ask me.
No doubt, sir.
No doubts? Cool. So um, we'll go to the next question. This is a fun question again. Velocity versus position time, position graph is given. Till now you are familiar with velocity and time graphs, but here I have played uh, a bit more. I have given you velocity and position graph. It looks something like this. Straight line. It looks like this. From this, I want you to plot, or I want you to imagine how will acceleration versus position plot look like. Not acceleration time, acceleration position plot. Given the Vx plot, I need Ax plot. Can you all recollect the necessary details and try to do this question? Given Vx plot, I need Ax plot, acceleration versus position. Can you all do this? We are meeting on Thursday, isn't it?
Yes, sir.
Yeah. Second question. Yes, Tejas, it is what you are saying makes sense, but yeah, you're right. Plot acceleration versus position is Udyat there in the meeting?
Yes, sir.
Yes. Can you tell me what is your guess? Is it a curve? Is it a straight line? How would the graph of AX look like?
Sir, here in like the graph you have drawn the Vx graph, sir, the velocity is decreasing as the position of the body changes, sir.
Correct.
So it's a decelerating graph, sir. So it will be accelerating less every second. So since you're plotting for position, I think it will be a it will be a straight line, sir.
It will be a straight line. Okay. Okay. Apeksha?
Sir, even I think it should be like a horizontal line, sir. If that
Oh,
plotted.
horizontal line. All right. Ah, Tejas is getting closer to the answer. Well, first takeaway. The takeaway is this. As the body is moving away from the reference point, body initially was at 0. It began moving towards right. Okay. So as it is moving towards right, what is happening to its speed?
Decreasing.
Decreasing.
Speed is
Uniform.
speed is decreasing. I'm not worried about uniformly or something. Speed is decreasing. If speed is decreasing, is it positive acceleration or negative acceleration?
Negative.
Negative acceleration.
Negative acceleration. So let us work this out. If I am plotting acceleration versus position, definitely I can rule out this quadrant. Why? Because acceleration is not positive, instead acceleration is negative. So it should somewhere, it should be in this quadrant only. The graph will not be in the first quadrant, it will be in the fourth quadrant. Is this clear to everybody?
Yes, sir.
Acceleration should be negative. So it will be in this fourth quadrant. How exactly will it look? Well, what is that one relation which I know about acceleration and displacement? I know only one relation between A and acceleration and position. What is that? A equal to V dV by dx, right? A equal to V dV by dx. How many of you know this? A equal to V dV by dx. We just discussed this a little while ago. Okay, A equal to V. Uh, okay, let's see, Apeksha. Let's see as the question progresses. Now, what is a dV by dx? I argue that dV by dx is nothing but slope of Vx graph. How many of you agree? dV by dx is the slope of Vx graph, isn't it?
Yes, sir.
Why? Let us see the pattern. What is the slope of xt graph? xt graph we just saw. Slope is equal to dx by dt. Y coordinate by x coordinate. What is the slope of vt graph? dv by dt. Similarly, dv by dx means it should be a slope of vx graph. Now you look at the vx graph. What is the slope? How can you figure out the slope? Is the slope positive or negative?
Negative, sir.
Negative.
Negative. Why negative? Definitely the slope is negative because
It's obtuse
Use
angle.
angle.
the angle is obtuse. So dv by dx will be some negative number. I don't know what number. Some negative number. Let that negative number be minus k. Let the slope or the negative number be minus k. So what do I have now? I know that acceleration is equal to minus k into velocity. Acceleration is minus k times velocity, where k is some number. Well, but I am not to plot a graph between a and x. I need a relation between a and x, but I got a relation now between a and v. So how can I use this to obtain a relation between a and x? We can do better. Can you express velocity as a function of x? Can you express velocity as a function of x?
Yes.
dx by dt.
dx by
That is there. V is dx by dt, but there t enters, isn't it? See, v equal to dx by dt. But I need velocity dependent only on x. How will I do that? I don't need any other dependence. Only how is velocity depending on x? You already have the answer staring at you on the screen. How do you know? How does velocity, how is velocity depending on x? You
Sir,
have the
a
answer on the
dx by
screen.
dv, sir.
How much? What is it?
A dx by dv, sir.
No, because there again a enters. I need velocity on the LHS, x on the RHS, something like that. You have the answer, but in a different form on the screen. Don't you know how is velocity depending on x?
It's decreasing.
Decreasing, but how will you express it algebraically? How will you write the equation of this line? How do you describe it in terms of quantities v and x?
Slope
Well,
into dx, sir.
no, we have a bit
I
of
is equal to mx plus c.
y is equal to mx plus c. Has it been done? Oh, ICSC, I guess. Yeah, yeah, y is equal to mx plus c. You're right. So, well, I take one line like this. This is y, this is x. I take any point lying on this line. I will mark it as x comma y. I need a condition. I need a condition which is satisfied by all the points lying on the line. Say, uh, all the points lying on the line should satisfy a condition that is called the equation of this line. So what does it do? If I take 5 comma 5, this point lying on the line? Is this point lying on the line?
No, sir.
No, it is not lying on the line. So if I put 5 comma 5 in this condition, should the condition get satisfied? It should
No.
not get satisfied. Why? Because this condition should be satisfied only by those points which lie on the line. So that condition is called the equation of the line. Now, how can I make the equation of the line very easy for you? Just remember this. This value, this value is called the y-intercept. What is it called? Y-intercept. Does intercept make sense? You have learnt about this, no? This is a transversal. The transversal is intercepted by two parallel lines. So what is this? This becomes an intercept. So what does it now make sense? Why is this a y-intercept? This is because this is created by the line with respect to y-axis. So this becomes y-intercept, and this has a symbol. The symbol is C, small c. This, what is the symbol of y-intercept? Small c.
C.
Right. Now, is this angle acute or obtuse?
Acute.
What is this angle? It is an acute angle. So, what is the slope of this line? Slope of this line is tan
Theta.
theta. It is also denoted by an alphabet called by name of m. Slope of this line is m. Y-intercept is c. You need only these two values to get the condition of the line. What is the condition now? The condition is y is equal to mx plus c. Y is equal to mx plus c. Sir, how is this a condition? Easy. M and C are already fixed by the line because theta, y already fixed. Suppose I substitute a point which is outside the line here. I put xy coordinates of a point lying outside the line in this equation. Will it get satisfied? It will not. LHS will not be equal to RHS. So this is the condition of a straight line, or we will call this as the equation of a straight line. Okay, y is equal to mx plus c. What is m? M is slope of the line. What is c? Y-intercept of the line. Now, can you frame a similar condition for our Vx plot? Instead of y, what do we have? V. And what is this? Some number, constant number, V naught. And what is the slope of this graph? I already told the slope of this graph is minus k. So what is the slope? Slope is minus k. What is the y-intercept? Positive V naught. From these two, can you build a condition of V and X together? V is on the y-axis, X on the position on the x-axis. With these two, can you write an equation? Y is equal to mx plus c. That is your basis. From there, can you construct an equation between V and X?
So V is equal to minus kx plus v.
Correct. V is equal to, if you compare, what do you get? We know M is equal to minus K. C is equal to V naught. X remains X. But instead of Y, what is the quantity plotted? V. So what is the condition that is satisfied by the Vx plot? V is equal to minus Kx plus V naught. Why did we do this? Because we needed velocity as a function of x alone. So Tejas, now you understood what is that I mean, what was I looking for? Velocity in the LHS, x in the RHS. Doesn't this satisfy? Everything
Yes,
else
sir.
known. V naught is a constant, K is some constant. So we know this. Now what do? We put this in A is equal to minus kV or minus K times, put this, minus Kx plus V naught. What is minus K into minus K?
Yes, sir.
K square.
K square X minus kV naught. So this becomes acceleration on the LHS, position on the RHS. So with this, I can aram se plot acceleration versus position graph. Okay, try doing this. How will this be? I know the equation now. A is equal to K square X minus kV naught. So is this a parabola? Is this a straight line?
Parabola, sir.
Parabola. Okay. Okay. Think carefully. Is it a parabola, straight line, or some weird curve which you don't know yet? All right. What
It's a straight
am
line,
I?
sir.
It's a straight line. You're right. So, what is the output? At every position, the output is acceleration, right? A I'm getting. I told you long back, whenever output is dependent directly on the input or only a single power of the input, what is the shape of the graph?
Straight line.
Straight line. Whenever output proportional to square of the input, what will be the graph? What will be the shape of the plot?
Parabola.
Parabola. Now look carefully. Output proportional to what power of the input?
1.
1. So what will be this? It will be a
Straight line.
straight line. Done. Straight line. And in which quadrant is a straight line?
4th.
Fourth one.
Here. How will the line look like? The line can look like this. The line can look like this. The line can look like this. So many things can go here. So how will the line look like?
Sir, but I have a question, sir.
Yes.
If the acceleration is in this case it is decreasing, sir. So at some point it will be zero, sir. So how can it continue to be a straight line?
At some point, what will it be?
The x value will be zero, sir.
X value will be 0. Where is the x value initially is 0? Where again x is 0? Initially, it was at 0, agreed. But as time progresses, it is moving away, 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 away from the reference point. So, where is again? Is it coming back to its reference point? Only then x will be 0. Apeksha. What was your argument? According to you, why x is 0?
Sir, I had the x in the y axis.
Oh, okay, okay. No, no, no. V in the y-axis. Yeah. Well, life is complicated or easy, however we make it. Here also we can make our lives easy by comparing this. Once I know it is a straight line, what is a standard form of a straight line? Y is equal to mx plus c. Instead of y, what is there? A. What is the slope? In the slope part, what is there? K square. Now tell me children, K square, can the square of a number be ever negative?
No, sir.
Square of a number. Square of a number can never be negative. So one thing is for sure, whatever line is coming over here, it can never be this way. Why? because then
Okay.
slope will be negative, but I want slope should be positive. So how should the line be? Line should be like this way. Oh, quite a good progress we have made. We now know the direction of the line. One more progress we can make. What is this? Y intercept. Y intercept is negative or positive?
Negative, sir.
Negative.
Negative. So as we told, the y intercept is a negative and it is a straight line with a positive slope. How would it look like? Like this. So this is the AX plot for the given Vx plot. From Vx plot, we got to Ax plot like this. There is no easy way around here. We have to do it methodically, analytically. So this is how you can do it. Are you all convinced with each step? Only if you are fully convinced, tell me to move ahead. I have other interesting questions lined up. Otherwise, I will revise this whole thing from the beginning. So tell me, are you all comfortable with each assumption, each step which we have taken here?
So could you
Tejas,
sum it up once more, sir?
sum it up. Okay, we can sum it up. Well, it all begins with a question. The question is Vx plot is given and I see the Vx plot to be a straight line. First takeaway, acceleration is continuously or acceleration is rather negative. Why negative? Because speed is decreasing as you move away from origin. Speed is decreasing. So acceleration should be negative. Point number one. With that, I rule out the first quadrant because here acceleration is always positive. It should not come in the first quadrant. The AX plot, it should come in the fourth quadrant. After this, what do I do? The only way I can relate acceleration and displacement is A is equal to V dV by dx. dV by dx is a slope of velocity position graph. And from the given graph, it is evident that this should be negative. So I equate dV by dx to be minus k because slope is negative. So some negative number minus k. So from there, what did I get? I got A is equal to minus k into V. I am only 5% away from the goal now. If somehow I can express velocity as a function of x or the position, I can easily plot acceleration versus position graph. So all it remains now is how to express velocity as a function of position. For that, I do not look anywhere else but again at the question. Velocity as a function of x. Yes, it is a straight line. What is a standard form of a straight line? Y is equal to mx plus c. From there, I can get v is equal to minus kx plus v naught. Substitute that in the relation k minus kv. From there I got the another dependence. A is equal to k square x minus kv naught. Comparing this with a standard form of a straight line, I got to know the ax graph will be a straight line with a slope positive, y-intercept negative. Y-intercept negative, slope positive. So this is how AX graph will look like for the particle. This involves a lot of straight lines, comparisons, slopes, positive, negative, how do you interpret, so forth. So now, yeah, Apeksha, any more details left uncovered, left not very clear on, you can ask me.
No, sir, clear.
Right? So this is how a JEE NEET question will be. Given Vx plot, how will you get Ax plot? And surprise, Karnataka CET 2018 question also more or less deals with the same. They have given a mains level question as as it is in their paper. Moral of the story, easy mains level questions can come in CET. This was asked in CET 2018, right? So can we go to the next question? Yes?
Yes, sir.
No?
Yes, sir.
Okay. Hmm. Oh, just to test your understanding, next question is this. Totally unknown quantities, all right? But whatever I am trying to draw, they're totally unknown quantities for you. Force and time. Force and time graph is given. Force and time graph is given. This angle is 45 degree. This is 1 second. This is at t equal to 1 second. This value is 1. This is 45 degree. Question is, find the change in momentum. Find the change in momentum. Sir, we are dealing with motion in 1D. How did this come in? Because this is very much related to one concept. Did we cover VT graphs for you in the board classes? Velocity time graphs? Did we?
Not much, sir, actually.
No, did I talk about areas in the
No,
VT
sir.
graph? Oh, no. We'll do that on Thursday. But before that, a sneak peek into whatever we have there. Find the change in momentum. So, how is a momentum related to force and time? From your lower classes, you know a relationship. What is it? Force is equal to change in momentum by time, isn't it? All of you are familiar with this? Hello?
Yes, sir.
Yes,
Force
sir.
is change in momentum by time. Well, so how can I find change in momentum alone? Change in momentum is equal to
Time.
force into time. Force is on what axis?
Y-axis.
I
Time is on what axis?
X.
What are you actually finding here? Product of y coordinate and x coordinate. Product. Whenever you're multiplying two quantities, what are you actually finding? You're finding area. Okay, so whenever two quantities are being multiplied and you have a third quantity which is dependent on the product of the two quantities, then how will you find the third quantity? Simply by finding the area. Okay, here momentum is dependent as a product of force and time. So I know to find momentum, what should I do now? Simply find the area. So what is this area? This is a right angle triangle. One of the angles is 45, so the other angle should also be
45.
45.
45. Now this angle 45, this angle 45. Sides opposite equal angles are
Equal.
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 So this side equal to this side. So what is measure of this height?
1.
1.
1. So what is the area? Area is half into 1
1 raised
into
to 1.
1, which
1.
is 0.5.
0.5.
You found the area, but what is the physical significance of the area? Change in
Momentum.
momentum is the physical significance. Similarly, what is how do you relate velocity, position, and time? Correct?
Yes.
Yes,
Generally, can I write the same as this?
Yes, sir.
yes,
Yes. If I plot a VT graph, I plotted a VT graph, it's something like this, and I ask you to find the position of the particle. How will I find it?
Area under.
Area under the plot, this area. Okay. Position of the particle is given by area under which plot? VT plot. What will slope of VT plot give? Same, if I want to extend this a bit further, what will be the slope of VT plot?
Acceleration.
Acceleration. A is equal to dV by dt, tan theta. That will give, the slope is going to give acceleration, whereas area is going to give position. So velocity time plots are extremely rich in information. It can give you two quantities. What are those? Acceleration and
distance.
position. Acceleration, how will you find out? By calculating derivative. Position, how will you find out? By calculating area. How do you calculate area? The mathematical name of calculating area of such an irregular figure is known as, you are already familiar with this. What is it? Integration. So
Integration.
if you find the derivative of velocity, you will get acceleration. If you find the integral of velocity, what do you get? Area, and area in turn is nothing but position. Okay, how can I prove this? Easy. You see this? How will you get the area of such an irregular figure? The area of such an irregular figure can be obtained by imagining it to be made of very small rectangular strips. Very small rectangular strips. Okay, I cut this whole figure into very small rectangular strips. So how do you highlight this? So these are the small strips. Okay, what is the width of the strip? The width of the strip, let us say this is x-axis, this is y-axis. The small distance, the small width, it will be
Yes.
X.
dx. What is this, dear? This is the y coordinate, isn't it? This is the y coordinate. What is this? Dx. So what is the area of this small strip? Area of the small strip is y into dx.
Dx.
Yes.
Now I want the sum of areas of all such strips which have dx, 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 dx as their lengths or the widths. So what am I doing? I am
Integration.
summing this all up, and we know whenever we sum very small quantities, many a times I can replace this with.
Yes.
Today you got to know what does integration mean pictorially. Pictorially, whenever we are integrating quantities, algebraically you knew. Algebraically what we were doing? Adding. Pictorially, if you want to see it graphically, what we are doing? Calculating area under the curve. Okay, integration gives you what? Area. Differentiation will give you what? Slope. You remember this? You draw a tangent, you calculate the slope of the tangent, isn't it? Was that taught to you? So the differentiation process will give you the slope of the curve. Integration will give you the area bounded by the graph. Okay, is this explanation clear, or do you need further clarity?
Yes.
Clear? Tejas?
Yes, sir.
Clear? Okay. So what is differentiation? Process of finding slope of a curve, tan theta, dy by dx. What is integration? Process of finding area bounded by curve, integral y dx. So now you know why, I mean, how does this make sense? Okay, how does this make sense? This is as if you are drawn a curve, you are finding the area bounded by it by adding all the small rectangular strips together. Area of all these rectangular strips is the area of the, or area bounded by the figure. Okay, just 1 minute. I'm extending, sorry, at the last minute. It is pretty interesting. Okay, what is this line? Can you write equation of this line quickly? What is the slope of this line? Slope
45
is
degree.
Y is equal to x
1.
plus c.
1. What is the y-intercept? Is this line having any intercept at all?
No, sir.
So what is the equation? We know y is equal to mx plus c. So y is equal to 1 into x plus 0. So it is y is equal to
X.
x. The condition satisfied by all the points lying on the line is y is equal to x. I ask the question. Find the area bounded. Find the area bounded by the graph till x is equal to 1. Till x is equal to 1. From x is equal to 0. In the sense, I begin from 0, I go to 1, I need to find this area bounded. How will I find this? There is a easy way, there is a hard way. What is this figure? Is it a rectangle,
Triangle.
square, or it is a
Triangle.
triangle? How to find the area of a triangle? Half into
Base into
base
Base
into
into
height. What is the height?
1.
1.
1. Why? Because it is an isosceles right angle triangle. So height is 1, base is 1. So what is area?
0.5.
0.5.
0.5. Wow. But if you use integration, what is it? Integral y dx. Where is x beginning from?
0.
Going till
1.
1.
what is y for us?
X.
X.
What is x dx? How will you calculate this? Integral x dx, we know the rule, right? Integral of x power n dx is x power n
N
plus
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 1.
1
1.
by n
N plus
plus
1.
1. What is the value of n?
1.
1.
So what is this if you use the formula?
X square.
Square.
By 2 between the limits 0 to
1.
1.
1. How do you simplify this? Put 1 in
1
place
square.
of here. So 1 square by 2 minus, put
0
0
square
over
by 2.
here. 0 square by 2. So what do you get now?
0.5, sir.
Isn't it, aren't they same?
Yes.
Yes, sir.
This is the physical meaning or the geometrical meaning of integration. So whenever we are performing integrals, we are adding, yes, adding what? Adding all the small areas to find the area bounded by the curve. Okay, so this is all that there is for calculus. Actually, you know the 12th standard calculus now. This is what you'll study in 12th standard. Okay, but you need in physics, so that is why we are uh, uh, giving it to you in advance. All the best then. Relax, and you have your daily schedule. You can start it. Sorry for the extension, but I wanted you to know this. What do we mean by differentiation? What do we mean by integration? Differentiation geometrically means finding the slope of the tangent. Integration geometrically means finding the area bounded. All right. So see you in the next class. Bye bye. Take care.
Thank you,
Thank you,
sir.
sir.
Thank
Thank
you,
you.
sir.
Thank you,
Thank you.
sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Bye bye.